Download this code from codegive.com, link in the description below. Keyword-driven test framework with Python and pytest. This tutorial provides a comprehensive guide to building a keyword-driven test framework using Python and the pytest testing framework. Keyword-driven testing, KDT, is a test automation technique where test cases are defined by a series of keywords or actions, rather than writing code directly for each step. This allows for greater flexibility, maintainability, and collaboration, particularly when non-programmers are involved in test creation. Benefits of keyword-driven testing ****. Increased reusability ***. Keywords can be used across multiple test cases, reducing code duplication. Improved maintainability ***. Changes to application functionality only require updating the keyword definition, not all test scripts. Higher abstraction level ***. Test cases are defined in a more business-readable format, making them easier to understand and maintain. Enhanced collaboration ***. Test designers, even without programming skills, can contribute by creating test cases using predefined keywords. Simplified test automation ***. Streamlines the automation process by focusing on defining the test logic through keywords. Framework architecture ***. Our keyword-driven framework will consist of the following core components. 1. Test data ***. Example CSV, Excel. This stores the test cases, where each row represents a test case and each column represents a keyword and its associated arguments. 2. Keyword definitions, keyword library. This module defines the implementation for each keyword. It maps keywords to Python functions that perform the actual actions in the application. 3. Test execution engine ***. This component reads the test data, identifies the keywords, and executes the corresponding functions from the keyword library. We'll leverage pytest for this purpose. 4. Reporting ***. This part handles the generation of test reports, typically through pytest plugins or custom reporting functions. Step-by-step implementation ***. 1. Project structure ***. Create a project directory and organize your files as follows. 2. Setting up the environment, dependencies. Install the required packages using pip. **pytest, the test framework itself. **open pixel, for reading Excel files, if using Excel for test data. *pandas, for convenient data manipulation and reading CSV or Excel files. 3. Test data, example data/test_data.csv. The test data file stores your test cases in a structured format. Here's an example CSV file. *test case ID ** a unique identifier for each test case. Description ** a brief description of the test case. Keyword ** the keyword to execute, maps to a function in keyword_library.py. *arg1, arg2, arg3 ** arguments to pass to the keyword function. You can add more arg columns as needed. You can also use Excel files for test data if you prefer. In that case, the OpenPixel package will be necessary. 4. Keyword library, keyword/keyword_library.py. This file defines the functions that implement the keywords. We'll use Selenium WebDriver for interacting with a web browser in this example. You'll need to install Selenium, pip install Selenium. Important notes about the keyword library ***. Locator strategy *** the enter text, click element, and verify element text functions demonstrate how to use different locator strategies, ID, name, spath, CSS selector, using Selenium. The locator string is split into by_type and locator_value. You should use appropriate locators based on your application's HTML structure. *error handling *. The value error exceptions in the keyword functions help to ensure that the keywords are called in the correct order and that required dependencies, like the browser being open, are met. This makes debugging easier. *global driver *. The driver instance is made available globally. This simplifies access across different keywords within the library. This approach requires careful management to ensure consistency, and the conf_test.py file, described later, handles setup and teardown. *robust locator handling *. The example shows how to handle different locator strategies. You should expand this to include all the locator types you might need, example link text, partial link text. *maintainability keep each keyword function focused and concise. Avoid putting complex logic directly within the keyword functions. If a keyword needs to perform complex operations, consider creating helper functions within the keyword_library.py file. *split equals 1 importance *the locator.split equals 1 method splits the locator string by the first occurrence of the equals character. This is crucial because spath locators can often contain equals within the spath expression itself. 5. Test cases test/test_cases.py. This file contains the pytest tests that read the test data and execute the keywords. Key points about test_cases.py *. read_test_data, * reads the test data from the CSV file using pandas. Error handling is included to catch file not found error. *pytest.mark.parameterize *. This decorator dynamically generates test cases from the data in the CSV file. Each row in the CSV becomes a separate test. The arguments to @pytest.mark.parameterize are the parameter names, test_case_id, description, keyword, arg1, arg2, arg3. These names correspond to the columns in the CSV file. *. A list of tuples, where each tuple contains the values for the parameters for a single test case. The list comprehension iterates through the rows of the pandas data frame and creates the tuples. *test_keyword_driven, *. This is the test function that pytest executes for each generated test case. *keyword_actions dictionary * maps the keyword strings, from the CSV file, to the corresponding functions in the keyword_library.py file. Dynamic argument passing with args *. The action, *args, syntax is crucial. It allows you to pass a variable number of arguments to the keyword function. The arguments are extracted from the arg1, arg2, and arg3 columns of the CSV file. Error handling the try, except block within the test_keyword_driven function catches exceptions that might occur during the execution of a keyword. This allows you to report test failures more gracefully. *pd notna, this is used to filter out nan, not a number, values from the arguments. Pandas uses nan to represent missing values in CSV files. Filtering these out prevents errors when calling the keyword functions. Argument conversion to string *. The list comprehension str, arg, for arg in arg1, arg2, arg3 if pd notna, arg, converts all the arguments to strings before passing them to the keyword function. This is important because CSV files often store all data as strings. Converting to string ensures that the keyword functions receive the data in the expected format. *pytest.fail, this is used to explicitly mark a test as failed. It's used when a keyword is not found or when an exception occurs during keyword execution. 6. Pytest configuration, conftest.py. The conftest.py file is used to configure pytest. In this case, we'll use it to handle browser setup and teardown, opening and closing the browser. Explanation of conftest.py asterisk. Asterisk at pytest.fixture, scope equals session, autos equals true, asterisk this defines a fixture that asterisk scope equals session, runs only once for the entire test session. Asterisk autos equals true, automatically used by all tests in the session, no need to explicitly pass it as an argument to the test functions. Asterisk yield asterisk the yield statement is what makes this a fixture. The code before yield is executed before the test session starts. The code after yield is executed after the test session finishes. The test session itself happens during the yield statement. Asterisk keyword underscore library dot close underscore browser, asterisk this ensures that the browser is closed after all the tests have run, even if some tests fail. This is crucial for preventing resource leaks and ensuring a clean test environment. 7. Running the tests asterisk asterisk. Open your terminal, navigate to the root directory of your project, keyword underscore driven underscore framework slash, and run the tests using pytest. Pytest will discover the tests in the test directory, read the test data from data/test_data.csv, execute the keywords, and generate a test report. 8. Adding more keywords asterisk asterisk. To add more keywords, simply 1. Add the new keyword to your test data file, data/test_data.csv. 2. Implement the corresponding function in the keyword underscore library.py file. Make sure to handle the arguments appropriately. 3. Add the new keyword and its function to the keyword underscore actions dictionary in the test underscore cases.py file. Example, adding a verify underscore page underscore title keyword asterisk. Data/test_data.csv, add to an existing test case or create a new one. Keyword underscore library.py asterisk. Test/test_cases.py asterisk. 9. Reporting asterisk asterisk. Pytest has excellent built-in reporting capabilities. You can use plugins like pytest HTML to generate HTML reports. Then, run pytest with the -html option. This will generate an HTML report named report.html in your project directory. 10. Using Excel for test data asterisk asterisk. If you prefer using Excel for test data, follow these steps. 1. Create an Excel file, data/test_data.xlsx, with the same columns as the CSV example, test case ID, description, keyword, arg1, arg2, arg3. 2. Modify read_test_data, in test/test_cases.py asterisk. Complete example project structure, for clarity. Summary and best practices asterisk. Asterisk keep keywords focused asterisk each keyword should perform a specific, well-defined action. Asterisk use meaningful keyword names asterisk choose names that clearly describe the action being performed. Asterisk handle errors gracefully asterisk implement robust error handling in both the keyword functions and the test execution engine. Asterisk use clear and consistent locators asterisk use a consistent locator strategy, example always use IDs when available, fall back to other strategies if necessary. Asterisk parameterize keywords asterisk design keywords to accept parameters so that they can be reused with different data. Asterisk documentation asterisk document your keywords clearly, explaining their purpose and the arguments they accept. Version control use version control, example Git, to track changes to your framework and test data. Modular design keep your framework components, test data, keyword library, test execution engine, separate and well organized. Consider abstraction for more complex scenarios, consider adding layers of abstraction to your keyword library. For example, you could create higher-level keywords that combine multiple lower-level keywords. This comprehensive guide provides a solid foundation for building a keyword-driven test framework with Python and pytest. Remember to adapt and expand this framework to meet the specific needs of your project. The key is to design a framework that is flexible, maintainable, and easy to use by both technical and non-technical team members. Remember to install the required packages, configure your environment properly, and test your framework thoroughly. Good luck.